Hello everyone, it's August 29th and yeah, so I think the gas furnace in my house is not working. It's getting cold and I think it's not working because I saw it's flashing red today and it flashes 11 times. The manual says the blow motor or the blow wheel is not working, and I check online and also I check the blow motor itself. Yeah, I think it's not working. The blow motor is making noise, but it's very hot to the touch. It's actually leaving a burn mark on the panel that's facing it. So I need to call for maintenance. Boy, I'm not sure how long that's gonna take. All right, we have a hard one today. That's interesting. Interesting choice for a Tuesday. Minimal number of removals to make mountainer. I feel like I've done this before. You may recall that an array is mountain if it's larger than 3 and there exists some index such that everything to the left and everything to the right. So it's okay. Given integer num, return the minimal number of elements to remove to make nums a mountain array. So the first example is 0, which is pretty much useless. Second example, okay, so let's see. 2, 1, 1, 5, 6, 2, 3, 1. It is guaranteed that you can make a mountain array out of nums. So it has to go up and go down, and then without any equals. I don't know. How do we handle this? Well, it's asking the minimum number of elements to remove. So the first thing you can think of is dp. Let's say dpi is the number you need to remove to make the start to I mountain. But then you have a new one. How do you handle the new one coming in? If you have the new one, well, if let's say dpi is the minimum removal, okay, to make nums 0 to I mountain. Okay. Now we are at I plus 1. Now we can say if nums I minus 1 is naturally smaller than nums I, then we're good. We keep moving on. Now the thing is, if nums I plus 1 is larger or equal to nums I, then what do we do? Right? If it's larger or equal to nums I. Well, if it's larger or equal to, so I know the previous I can already do this. If I have the new one, which is larger or equal to the previous one, now I can remove it, sure. But I can remove it, and then this one will be just slightly higher. Or I can choose yeah, I can choose to remove it. Or I can choose to not removing this, but I'd say if I basically just say, do you want to keep it or not keep it, right? And if you want to keep it, then you have to go back to find the first one that's bigger than this, right? You have to remove all that because otherwise it's not going to be, right? So you have to do that. Yeah, that's the only way to keep it, right? But then we bifurcate, right? Because we have a situation where we don't keep it, we have a situation where we keep it. And if this is the end, then we can say yes, then we'll just remove it, right? We'll remove it. But what if we have scenario like this? We have a bunch and then we're keeping it is a better strategy. Plus, we're not sure if we should, reevaluate the ones before. Yeah, that's the thing. It depends on like which. Huh. Maybe you can run I don't know, monotonic. So if you do a monotonic, you will know the monotonic increase from right to left, from left to right, so it will be 2, and then 1, and then 1, 5, 1, 5, 6, 1, 2, 1, 2, 3, and then 1. Alright, so left to right, the biggest is this has 3 and this has 3. Right to left, we have 1, 1, 3, 1, 2, 1, 2, 6, 1, 2, 5, and 1, and a 1, 2. So we have the longest is this, and this. So maybe what we want to do is to see if we can match the two. So I have the left half is here, and try to see if we can match to the right. How do you match? I mean, in reality, it's not going to be numbers. It's just going to be indices, right? We'll have indices. So for each one, I can try to match everyone. Okay, for each one, I try to match every single one, and I can get a result, and eventually one of the match will be right. Because if you think about it, you're removing, right? You're removing, it is just like a monotonic increasing from right to left, left to right, and a monotonic, yeah, you can call it decreasing. Can we do decreasing? 2, 1, 2. No, I think I still do increasing from right to left, right? Because you're just removing them. And then, yeah, and a further proof that this might work is the length is 1000, because this algorithm will run in O(n) squared. A left to right monotonic increasing, that will, to produce these, that will run O(n). Right to left monotonic increasing, that will run O(n) as well. But then if we want to match the two groups, then it will run O(n) squared. And it will work for this one as well, because let's try this one as well. So we have 1, 3, 1, right? So this way we have 1, we have 1, 3, and we have, you know what, we shall not say, we shall use index, because at the end of the day it's going to be index, right? So we have 0, we have 0, 1, and do we pop it? That's a good question. Do we pop the original or do we not pop the original? Basically, when we have equals, do we pop it? Yeah, I think we should pop it. So now we have a 2, right? So this is left to right. Now right to left, we have 2 and 1, 2. Ooh, how are you gonna do that? Array list can add front. Actually, I don't know. Can array list add to front? What's the performance? Yeah, I think we have to do a queue. Yeah, we have to do a queue. In fact, we don't even need to do the whole thing, right? All we need is the end. We need a length, and so this one we can translate to end is 0, length is 1. End is 1, length is 2. End is 2, length is 1, right? So this is on the left. On the right, I can do something similar, right? So the first one we can say, this is the end, this is a start, right? Start is 2, length is 1. And then we push this, yes, so we say start is 1, length is 2. And this, down, 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 to push everything, so start is 0, length is 1. That's the right side. Now we try to match, so we start with 0, right? We need to match anything that's larger or equal to 0. because the and is 0. Equal to, I hope this 1, this will be 1. This length is 1, and as 0. This is start at 1. So yeah, so this is length is 3. This length is 2, right? And then this one we go the same thing. Everything we go the same thing. Yeah. What else? Can we make it easier? Map. Yeah, I'm thinking. Hold on. I am thinking what will be the best way to get it to work. Well, let me see. And then the length has to be, because we are creating the one that's at the end, so it has to be larger equal to 3, right? And you do have to go through every single one. I don't think there is a way. I mean, we can sort. No, but if we do the indices, then we can directly go, like for 1, I won't need to go to 0, I go directly to 1. But you don't have to go through every one of them. But you want to know the maximum, right? So if I have this, right, from 0, 1, 2, 0, 1, 2, 3, 4, and they have some values, right? Some v1, v2, v0, v1, v2, v3. What I want to know is like a max, right? Like a prefix max. If I do say, well, I'll end at 0, okay? Then we need to know the prefix max for 0, what it is. If I end at 1, so I need to know for 1 the prefix. Yeah, let's do this. A prefix max, right? A prefix max. A prefix max. So we end at 0. That definitely only 1. Right, so we have actually 0, 0, 1, 2, right? So this is a 1, and at a 1, and at 1, yeah, if everything as you end at here, what is the largest? So end at 1 is 2, so it's going to be 2. So end at here is going to be 1, so the maximum prefix max. Oh, prefix max. Oh, we cannot do prefix max. We have to do a 1. Because if I do here and a 2, right, I want to know the previous. Yeah, you have to go with 2. There's no other way. Yeah, it's not a prefix max. There's no other way. You have to go with 1. Right, because it's not 2. But what I was thinking is, because I ended at 2. Oh, it's fine, because I ended at 2. I need to find. Hold on. I start with some position. So I need to know, like, all these, what's the maximum, right? So if I and I here, then we have a chance of getting a maximum. Yes, we shall, because this one is saying we're starting at this position, now like index 2, right, going down. So I want to know the previous indices, ending at previous indices. What is the largest one I can get? So this is 2. It is a prefix max, right? So when it's 2, we're adding a 2, we check the 2, okay? We're adding a 2, so basically this is saying we can have prefix max at 2, right? But there's one complication that we might overcount, is if in fact we have overcount here, because that is 1, right? 1, and so I do 1, so this is going to do 2, so you will get a 4. How do I prevent that? So instead of doing this, we need to do it like this. If it's reached at this position, you say 1. If it's not reached, you say 0. So when it is 2, I check it's a 0, so I can use it directly, so it will be 3. When it's a... Actually, I start, yeah, and then we start with 1, it's a 2. I go see it's ending at this one, so I don't take it, so I need to minus 1. Ooh, I think this might work. And I don't think I've done anything similar before. So basically, we need a okay. Now we say it's gonna be an int pre-sum, pre-max. Max length of monotonic increasing array. In nums 2i plus 1. Pre-max I, okay, equals. And then whether the max is reached at nums I. Okay.
Oh.
We need a max. We can have a max. We need a prefix or stack. No. Let's not do a stack. Dude, what do I need to do? I need to do the previous. Yeah, let's use a stack. Okay, integer. Stack. New stack. Okay. And then I will say for int I 0i smaller than n I plus plus. Okay. And then we say while stack dot is empty. Okay, stack is not empty, and stack dot peak nums stack dot peak. Actually, it doesn't really matter, right? We can put actual number into it. We don't really care. Yeah, we don't really care. Let's just say stack dot peak is larger or equal to nums I, right? If that's the case, stack dot pop. We pop until we cannot pop. Then we say stack dot add nums I. Okay, and here we say premax I 0. Ooh wee. What if it's the same length? What do you do? If the previous max can hit the same, you only record it if you are the one that make it. Okay, so this is the max length, right? Max length. So you check your current length, right? Your current length. If stack dot size, this is the current length, is larger than stack I minus 1, 0. Okay. If I is equal to 0, or under these circumstances, then we say, that's not stack, my bad, this should be premax, right? Under these situations, we say premax I shall equal to stack dot size. Actually, no. 0 is a stack size, and premax I1 equal to 1. Right, we say the max size is reached because of nums I. Right, because of nums I. Otherwise, that means it's reached not because of nums I. Right, so the size either is equal to, or then we premax I0 shall equal to, it's not stack size, but premax I minus 1, 0, because your current size is not bigger than the previous size. The previous size is bigger, so you're smaller, so we just follow the previous, and we say premax I1 is equal to 0, right? Max size is reached because of a previous unknown. Okay, so we'll do this, right? We'll do this until we hit the end, and then we're gonna do, let me also add one more. We can say monotonic increasing array from left to right. Okay, and here we're gonna say monotonic increasing array from right to left. And for first, stack dot clear, and then int res equal to, well, we just need a not res, it's the longest mountain equal to 0. And then for int I equal to, we'll say n minus 1, I larger equal to 0, I minus minus. Okay. All right. For each one, same thing. While not stack dot is empty, and stack dot peak is larger equal to nums I. Now we say stack dot pop. Okay. And then stack dot add nums I. Okay. Now we have I, and then we have the length. Then we go to the premax. Right? We'll go to the premax. Then we'll say int current length. Right, current length shall equal to premax I, right? Premax I. This gives you the longest, right? 1. Is it equal to 0? If it's equal to 0, then it should be stack dot size plus premax I 0. Okay. Else, okay, I think I'll do a little bit different because you have to do the stack size anyway. So do stack size plus, right, premax equal to 0 if, oh, nice. We can just say premax I 0 is the length minus, right, minus this. Because if the premax is not reached by nums I, it's not reached, then we can add these two together, right? The stack size, the current stack size, and the premax, the prefix sum max, the left to right monotonic increasing array. We can add these two together. But if it's reached because of nums I, then we have to remove 1. Oh, that's a brilliant design. I didn't even think about this design earlier. Now we get the current length, but we also don't need to say current length. All we have is longest mountain shall equal to, let's just call it longest, right? So we'll do longest shall equal to math.maximum longest and this, right? So we want to get the longest, and once we get it, we just return n minus longest. That's the number we need to remove. Oh boy, let's try this one. If this one works, that's actually not bad. That's actually not bad. Okay, it works for this. Let me throw some curveballs at it. That's a curveball. So usually I do something like that. Oh, I was thinking, no, it will not overflow. Yeah, I usually have like overflow situations. Okay, let's try this. Cannot form mountain. Oh, really? Oh yes, dude, this cannot form mountain arrays. Damn. Didn't realize. Ugh. In right. The last one's not right. I thought it was correct. Okay. So we definitely have some issues. Can we make it a little bit smaller so it's easier for me to debug? Good. Let's remove some more. I don't know, just randomly remove some. I don't know if it's working. Nice, we're still wrong. I got 10. Is this good enough for you to debug? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A little bit. Can we keep removing? Let's just remove a bunch of stuff and then see if it's still wrong. Yeah, become correct. Okay, how about remove this part? Yes. Okay. I can handle this. Alright, I can handle this. Alright, let's see. I think we can also make it slightly more friendly. Yeah, whatever the shoot this is. Okay, so this I think still gonna be wrong. Yep, this is still wrong. Perfect. All right, let's debug this. Let's see what we got wrong. So what we have 23, 43, 45, 75, 75 again. 46, 6, 57, 78, 643, and 46. Okay, so the way I'm doing is the size. So we have 23, 23, 43, 23, 43, 45. Yeah, I think I can eyeball this thing. So the arrays that you're looking for, right? Our prefix max array. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dude, you're so bad. 1, 2, 3, 4, 5, 6, 7, 8, 9. Damn, 10. Okay. So a start is gonna be 1, 1. Not because I handle this. This is gonna be 2, 1, 3, 1, 4, 1. This will pop this. Okay. Nah, this is terrible. Damn. Right underneath it. 1, 1. Okay. This will be 2, 1. This will be 3, 1. This will be 4, 1. This will be, I will pop this, so this will be 4, 1. Right? The way we're doing, no, it's not. Because the same as before. Right? You said it's same as before, only larger than. So this is actually 4, 0. This will pop. That's also 4, 0. Because it's reached before. This will all the way pop. This will be 1, 0. This will be 2, 0. This will be 3, 0. 4, 0. Right, and the last one is actually this one gonna be 2, 0. Okay. So that's left to right. Okay, so let's make sure that we got it correct. How do we do this? We can. Damn. For. I kind of want to use debugger for this. Yeah, I think I want to use debugger for it. It will be faster. IntelliJ. It will be much faster than any other methods. Yeah, let's run a debugger. Update upgrade online now. License has expired. Oh shoot. That is true. I didn't have a license anymore. Can we use the... Ugh, I forgot about this. I was like, I don't think I was using anything. Doesn't IntelliJ has a community level? Ah man, I have set up the community level. Can start trial. Shoot. Shoot. Okay, I need to deal with this later. Damn. Because Java-wise, I didn't set up... I didn't set up the exit. Ah, shoot. I have to use the open source version, the community version. Damn. Not today. We have to print. I don't want to print. Okay, so we have a role in premax. Okay. I think system.out.print, but don't say print line. Then we can print row. No, arrays.toString row plus, I don't know. I'm purely guessing at this moment. Did that work? Oh yeah, it works. 112131414040404040. My bad. We're doing prefix. Yes, these are all 4 zeros. Oh, these are all 4 zeros. Yes, they're all 4 zeros. I don't know why I didn't realize. Yeah, these are all 4 zeros. Which is correct, because if you want to do this, we have 4 zeros. Okay. So now we're going to go from right to left. So right to left in this position is 1, right? So you have 1 here, right to left. And you go here. And you say it's a 4. Because left to right, the maximum is 4. And you say ending at, oh, hold a second, ending at. Oh, you cannot do it that way. You cannot. You simply cannot do it that way because you don't know. You're just saying that we are ending at here, right? But this is a 4. So you can go before to find the fourth one. The fourth one is 75, right? And you're saying that adding you will be 5. And the longest is going to be, no, it's not going to be 5. Yeah, because what you don't have is you don't know whatever the previous, the top, and a current, because we're doing this the previous, right? And then you're doing here, right to left. So this one and this one, you don't know which one's bigger, right? You don't know which one's bigger. The current requirement is for this to be smaller or equal to this one. I meant, yeah. Or actually, it doesn't really matter. What it matters is, yeah, it doesn't matter. Like if it's smaller, it works. If it's bigger, it works as well. Yeah, it works. It doesn't really matter. It doesn't matter. It doesn't matter. So for this, we have a 4, and so we get a 5, right? So the length is 5, and okay, expected is removing 3, which is we need to get 8, right? We need to get 8. We remove 3, we get 8, and the answer I get is 4, which means I only get 7. Yeah, that is problematic. So the first one is 5. Second one, now we have 2, right? We have 2. Now we have 6, right? And this one is also 4, 0. And this one is 3. No, not 3. This one's 2. So this one is 6. So this is 1. This is 2. This one's also 2. So that's also 6. This one is also 2. This one becomes 1. Oh. And this one becomes 1. Damn. And this one is 2. This one is 2. Because you pop this, right? This one is also 2. That's not true. This is a 1. Oh yeah, this is a 1. This is 2. My bad. This is a 2. This is 3. This is what we get. This is where I get my answer. And this is 3 as well. And we don't have any. So I got 3, 75, 46, and 6. All right, on one side. And on the other side, I have oh, actually this is also not right because this is the same as the previous. So you cannot even take 75. So you have to take this 75. 1, 2, 3, 4, 5, 6. Yeah, I only get 6. Wait. I only get 6. How did I get to 7? How is this expected is removing 3 numbers? Oh, hold a second. Hold a second. I think you're removing this and removing this. Yup. Oh. Oh. Yeah, this is right. And this is also right. And I got 46. Ah, I see why it's not working. Because you got 46. That is 4. And you remove these. You got 6. You remove everything. Then you start from 6. So when 57 comes in, I don't get to use what's the previous. Ah, I see. That's the problem. So what? So I don't know. And what was also troubling because my output is 4, which means I got 7, but now I can only find oh, it is 7, right? So because this is 3, then 3 plus 4 is 7. Okay, yeah, I see how I get it. Yeah, but that is actually not correct. That's not correct. Okay, so as we're building the monotonic array, so this one's fine. So all the way to this 75, that's fine, right? And then when this 75 comes, we can keep it. And then we pop, we'll get a 4. Or we cannot keep it. Nah, that's not how we want. It's this 57. Okay, the difficult part is with this 57. No, when 6 comes in, it will remove everybody. Right? It will remove everybody. And when 57 comes in, it's based on 6, which it shouldn't. Right? Which it shouldn't. So what 57 needs to do is to check. Yeah, so when 57 comes in, I need to check one by one, okay? One by one. What is the longest ending at every single position? So yes, so for 6, the longest ending at this position, monotonic increasing, is going to be 1, right? It's going to be 1. It only has 1. There's no other way. But 46, the longest is 4. 75, the longest is 4. This is right. And then, in fact, it is monotonic increasing, but it's slightly different. Okay, it's slightly different. So from each one, we will do not popping, right? Not popping. We just go through everything, because I have the longest ending at. So we go through everything and then we record. This, we go through everything, we record. This, we go through everything, we record. 6, we have to go through everything, then we record. 57, we go through everything, then we find out 57. Okay, so that's a completely new kind of finding. Okay, that's a new kind of finding. So what we're doing is ending at this. What's the longest? 1, 2, 3, 4, 4. This one is 4. This one, but don't pop. We just go through everything. And this is 1. Right? Yes. And then this, we go through everything. And then this will be 5, 6, 7. This, no good, no good, no good. That's a 2. No good, no good, no good. That's a 4. Right? That's a 4. So we got a 4 out of this. So that is the longest monotonic from left to right. So it's very different from what I was trying to do earlier. Okay, so now we got a left to right. Now we have to go from a right to left. Right? And right to left. And everything's ending. Right? Everything is ending. So we go right to left. So can we also make a monotonic, now a prefix max? So we 1, 2, 3, 4, 4, 4, still 4, 5, 6, 7, 7. Right? This is monotonic. This is not one. This is the prefix max. Now we go from here. So that's a 1. Right? And I see it's a 7. But it's a 7, 0, because this 7 is created here, right? So therefore we get an 8. That's how we get an 8. Oh, crap. Okay. Okay, so now this one, yeah, it is a 2. But that's a 7, 1. Right? It's a 2, so we have to remove 1. And this, that's a 2. So yeah, we can do like this because this is gonna be a 1. This will be a 2. This is a 2. And this, try. This is gonna be a 2. This is going to be a 1. And this is not gonna be a 2. Well, this is gonna be a 2. And yeah, this is a 2. And this is gonna be a 3. Right? But then this is gonna be like a 7. Right? That's not what we want. This is gonna be a 3. This is gonna be a 3 as well. And this is going to be a 2. This is going to be a 2. And this is going to be a 2. Doesn't matter. Right? Doesn't matter. We already found it. It's gonna get okay. We will change how we do the monotonic. So there is still an Owen squared part in here. All right, monotonic array from left to right. But we do not pop. Okay, so if we do not pop, what's the point of using a stack? Right, because we have to check everybody anyway. Yep, but I don't think there's a point of using a stack. So we will do this. Okay, so we have I, right? Then we don't need to go from I equal to 0. We can pre-fill. So we can pre-fill this. We can say, so we always check. We go from here, go to the previous, and then find the one with the maximum count. Can we use the prefix already? Like for the 6. No, for this is the key. And go, I find something that's smaller than me. And the largest two so far, so this is gonna be, yes, I can just go straight with prefix max. I can go with prefix max directly. And this is the same, I find, and then only, oh yeah, if I do prefix max, then I don't have to go all the way down, right? I just need to go find the first one that's smaller than me, and I find the first one that's smaller than me, and I plus 1, right? Because that is the maximum ending at here, right? The maximum ending at this position. The maximum ending at this position is a 4. But that's not the first 4, so this is going to be... we also don't need this 0 or 1, because we just need to compare to the previous one. Oh, that changed a lot of things. Okay. So we'll do, so here is maximum length of monotone increasing array enums this to the end. Cool. Okay, that's cool. And we do this, and what do? We go for this to for int j equal to I minus 1, j larger equal to 0, j minus minus. Okay, so the first one that is smaller, so we say if nums j is smaller than nums I. So yes, then how do we do this? So everybody will be by, so let's say pre-max I always start with 1. Okay, and then if this, then we say pre-max I shall equal to max.maximum pre-max I. Do we need that? I don't think so. I think we can just go pre-max I shall equal to what? Shall equal to pre-max j, because nums j is smaller, so we go to this plus 1, and then we break it. Okay, so when we first start, it's going to be 1, and then everything, if it's smaller than, then we add 1, and then we break, because we always get the maximum. That's not true. We get the max. Okay, so we'll get the max first. Yeah, we find something, we pre-max j plus 1 is the current max, right? And we need to compare it to the previous max. So it'll be like something like this. Max.maximum pre-max I minus 1 and this. Okay, and we guaranteed I minus 1 will be larger equal to 0. Yeah, so this is do prefix max, right? We're doing prefix max here. We do this, and then we do the premax j plus 1. Premax j plus 1. And then we do this, we'll break it, and then blah, 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 blah. So we don't need this, we don't need this, we don't need this. So once we go through, we get a pre-max everything. And then we do the monotonic non-increasing, the same thing. It's exactly the same thing. And we don't use this, we use this. So for I is doing this again for int j. Oh, but do we need another array for this? Because we need to keep track, right? We need to keep track of, yeah, we probably, so we have a premax and we need now a length, right? Monotonic length. Okay, and then for int j shall equal to I plus 1. Again, monotonic length I shall equal to 1. Everything starts with 1. And then this is going to be j smaller than n and j plus plus. Okay, so for everything, again, it's the same algorithm for, so nums j, right? If it's smaller than nums I, because I, we find a nums j, right? If that's the case, then monotonic length. Hold on, why don't you do premax again? Right? Why don't you not do premax again? I think you should do premax again. Because it's the same thing. So premax, you just go from right to left, right? You should do premax again, and then you can break it. You don't have to keep going because you have something bigger you don't know. Right? You find the first one that's smaller than you, but if it's not the maximum, hold on, let me think again. This prefix thing. This prefix thing is very interesting because here, right, 57, I find the first one that's smaller, and this one tell me there's a 4, but it's not ending at this one, it's 4. It's just saying in the previous we have a 4, but you don't know if the previous you have a 4, the end is bigger than you or smaller than you. Yeah, I don't think it works. I don't think you should do prefix. I mean, this one, luckily we do, but if I don't have 46, right? If I don't have 46, this will still be 4. And at 57, you will think will be 5, but it's not. Because if 57, you look in previous, it's going to be a 4. So no, this does not work. Unfortunately, this does not work. The prefix max does not work. What does work is this thing. It's just the prefix, it's just the monotonic increasing length. And you're going to do the monotonic increasing length the same way, right to left, okay? And you will have to keep track of this, unfortunately, you have to. But, I mean, we can use the same array because we can remove it, right? The first one, we done it, we can remove it. And because it's ending, so we can do whatever, and then we will do this number and then -1. So this, yeah, exactly. So this one will just be 4, right? And if you think about it, we use this, and we have, because we say ending at this, right? Ending at this. So previous increasing ending at this is only 4. And then we do, okay. Yep, it's unfortunate, but this is how it has to be. I cannot do prefix max. It's just gonna be monotonic length, left to right. Okay, so mon-len left to right equals to max length of monotonic increasing ending at nums I. And this is going to be mon-len is equal to 1. And then for this, then this we say mon-len lambda equal to monotonic length left R, right? It's gonna be I and monotonic length left R j plus 1, because we have a j that's smaller than it, and then just gonna be this plus 1, and then we keep, then we don't break, we have to go through the whole thing. Okay, and then increasing from right to left. Now that's the thing, we don't need a second array, we'll do it in place. Damn. Okay, so we do it in place, which is fine. Okay. We will reuse mon-len and update it in place. Right, in place for right to left traversal. Okay, so now this is, don't say it yet. Okay, we do this equal to 1, and then we will accumulate what this one is going to be. So it's going to be this. If it's this, then we say len equal to max.maximum, this len, and monotonic len j plus 1. Exactly the same. Okay, it's exactly the same. I just realized I don't need this. Right, length is, this is exactly the same, because we're going right to left, and everyone, you just check, whoever is smaller than you, then you use its thing. Okay, so now we get a length, then we do longest, and we will do this. Oof. All right, so now it's gonna be its length plus monotonic len I minus 1. Okay, once we've done this, monotonic len I will be len, and then we do this. Oh boy, let's try this. Yep. Okay, let's return to our previous. Okay, so yeah, let's do, I remember it's even longer. There we go. Oh shoot, I think one of them is not. Oh, it's good. I think this might be it. This might be it. Wow, 1 hour and 9 minutes. Monotonic, left to right, let me see. Find the longest monotonic monotonic increasing, right, increasing array from left to right, ending at each nums I. Save it in monlen array, right, save it in the monlen array, such that monlen I is the max length. Do the same thing from right to left, and each time, and for each nums I, we know, right, its longest length, monotonic increasing, monotonic, I spell monotonic wrong, right, monotonic increasing array, right to left, we know its longest length, right to left, and its longest length, left to right, right, and therefore the longest mountain, right, array with nums I as the peak is the left to right length plus the right to left length minus 1. Runtime O(n) squared. Because this part is O(n) squared and this part is O(n) squared. Okay. Let's pray. Let's pray that this one works. Come on, it has to work. If it does not work, we'll have a very interesting conversation. Oh my god, it does not work. No way. Man, it's getting late. Why? Alright, no panic. Maybe we can debug this. Alright, did we at least pass some? Oh, we passed quite a lot. Maybe it's an edge case. Maybe it's just an edge case. Okay, 9, 8, 1, 7, 6, 5, 4, 3, 2. Wow, it's very edge. Very edge. Expected 2. You need to remove 2. Oh. Shoot. I know why. Because indeed I removed this, but this is not. Okay, okie dokie. So how do we fix this? Man, how do I fix this? I think it's just an edge case. We just need to fix this. Let's see. Monotonic increasing. This is 1. This is 1. This is still 1, right? This is still 1. How many is it? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 in total. This is gonna be 2. Ending at this. This is gonna be 2. Ending at this. This is gonna be 2, 2, 2, 2. This is a 1. Right? That's the length. So this is this way. So now we go this way. This is gonna be 1. That's actually 0. We should actually get that longest is. Oh yeah, it's okay. It was the longest. We will always get to 3. That's fine. So this is a 1, 2, 3, 4, 5, 6, 7, which is good. This is 9. right? This is not 9. This is 8. Basically, it's 1, 7 all the way down, right? This is 8. Here, this is going to be 1. This, as I skip this, this is going to be 8. Which is fine, I think. Actually, it's already not fine. This is already not fine. And this will become 9. Right? And 1 plus 9 is 10. It's just like everybody, just remove 1. So, how do we... So this... Maybe I should set it to 0. You know? We say it's the peak, but it doesn't have anything on the left. It doesn't have, like, if this by itself, it cannot be a mountain array, right? Well, it's a peak, and it doesn't have anything on the, because we're thinking about monotonic increasing, and for this value, it doesn't have anything on the other side, right? It doesn't have anything on the other side. And then for this also, it doesn't have anything on this side, right? It doesn't have anything on this side. So when these two, so in this case, I just have boom, this thing, and then this just by itself, right? Just by itself. But it doesn't have anything on this side. So it has to be increasing. I already have something on this side to be counting, right? If it's 1, 2, I'll count this as a 2. But we don't count 1. There's no such thing as 1. There is no such a thing as a 1. That is a very interesting point. That is a very interesting point. So if there's no such a thing as a 1, yeah, so you're either 0 or you are, so in this case, this is also going to be 0, right? This is also 0. And this is going to be 2. Damn. 0 because it's the start. 2 because I do have 2. You might consider, what if I still do a 1? If I do a 1, then this will be 6. Now 1 plus 6 is 7. That's also not right. Yeah, we just have to set this as 0, and these are the 2's. And this, this will be 0 again. Right? So if it's a 0, if you find something that's smaller than you and a 0, you immediately become 2. And if you find something that's smaller than you that's larger than 0, you plus 1. And if you don't find anything, it will be 0. Okay, and then right to left, again, this will be 0. This is 2. 3, 4, 5, 6, 7, it's all good. And this becomes 0 again. And this, we'll get 8. That's true because monotonic increase is 8, but we cannot plus this because it's a 0, which means we don't have anything on the other side. So if it's a 0, we don't do it, right? We don't do it. Or you can say we do it, but no, we don't do it. If it's a 0, we don't do it. Okay, so it seems to be a small change. So what we do is we'll start this with 0. Okay, and if this is smaller than that, and nums and monolength j is larger than, I think we have two situations. I think we have two situations. So here is monotonic length j if it's larger than, if it's equal to 0, right? You find something that's equal to 0, then you become 2, right? Otherwise, you become previous plus 1. Here is the same. We'll set it to 0, and we'll say monotonic length j is equal to 0. If it is, we do it. We do this, right? So once the length comes out, we'll say if monotonic length I is larger than 0. If it is, then we do the longest. If it's not, we don't do it, right? We don't do it. So this is hold on, we need to if the monotonic array is only of one element, don't count it. I mean, we can set to 0, we can set to 1. Actually, it doesn't really matter. Yeah, it doesn't really matter. No, it doesn't really matter. What matters is when we find it says 1, we just don't do it. All right? What matters is here. If monotonic length I is larger than 1, then we do it. Otherwise, we don't do it. Wait, run that. Still good. And we run this. Yup. We don't need this 0 or not issue. We just need to check it has to be larger than 1. You're kidding me. You're killing me. 87. What was the previous one? Previous 83. So we almost there. We almost there. Okay. Let's try this. What the heck? 4, 5, 13, 17, 1, 7, 6, 1, 11, 2, 8, 10, 15. Oh, I need a bit bigger. 3, 9, 12, 14, and 16. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay? Oh, 17. Output 9, expected 10. Output 9. Okay, so output 9, which means I find 8. Length is 8. Expected 10, so if find is only 7. Okay. So 1, 2, 3, 4, 1. This is going to be 3. The longest is going to be 3. Longest is going to be, oh my goodness, 4, right? Because I can have 4, I can have 4. So it's going to be 2. 8 is going to be 4. 10. I have 5, 6, 3, 5, 12, 6, yeah, 7, 8. Okay, so my answer is the target. The target is what? 10. Target is 7. Okay, target is 7. I think I know. Yep, I think I know. I think this is it. Yep, left to right and right to left must be monotonic array. Must be of length at least 2. Come on, this is it. Yes. Oh Lord. Oh my. My. 1 hour 25 minutes. Tough question. I mean, you think it's tough, but it's. I mean, if you look at the algorithm itself, it's not that complicated. It's the same, right? It's just monotonic left to right and monotonic right to left. I mean, a lot of time was spent. Okay, I was first thinking about DP, and DP was not working. Right. Yeah, DP, I couldn't see how DP worked. And then I was thinking monotonic array, which was on the right path. And I went through a couple iteration of design of how this array needs to be. I think the issue was I was trying to use the prefix max, and that did not work because I did not realize two things was wrong. First was the way I was doing the monotonic array. I was popping stuff, and if you pop stuff, you don't really get the actual max, right? You don't get it. So that one was the first error, and I was trying. I mean, I was just trying to be cute, you know. The length of the array is 1000, so ON square will work, and also expected. But I was thinking, yeah, it's monotonic array. Why do ON square when you can do ON? And I tried ON, and it didn't work because it was wrong. If you're popping stuff, then you are not getting the true maximum length monotonic array ending at each position. So that's the first error. And the second error was I was trying to be cute. You should not try to be cute. And I was trying to use prefix max, and I was thinking, yeah, if I do prefix max, that's definitely gonna save time when we do the matching, right? When we do the matching. But it's not gonna work because prefix max, you never know what was the value that makes the max previously. And if the current one is smaller than the previous one, then it actually doesn't work. So you have to go through them one by one. So yeah, these two mistakes cost a lot of time. Because basically I have a previous design and then it just doesn't work, and I redesign it, it doesn't work, right? The two errors. And the rest is just some oversight, right? The rest is just some oversight, like this condition I didn't consider earlier. That was an oversight. Yeah, so if we could stumble upon the right path, I think we can do it. We can definitely save half an hour, but it's still looking to be like a 1 hour effort. Okay, let's just skim through the solution and then try to see if we are thinking about the same thing. They can use DP. I mean, I don't know. Do you think this is a DP? Okay. You can say monotonic length is a DP. Yeah, you can say it's a DP. ON squared binary search. Okay, let's just see. Yep. Right to left. Yep. Of course, they use 2. And yeah, this is the thing. You see, it's exactly the same. It's exactly, I was still trying to be cute, only using one array, but overall it's the same. Exactly the same thing. This is the part that I missed. But otherwise, it's the same. Oh, dude, it can be O and log n. Ooh boy. Okay, so need to read this. Damn, this list is getting longer and longer. Yep, need to read this. You can do this in NlogN. And it's not that complicated. Oh, okay. it is complicated, but maybe they did. Yeah, I think the binary search was not using the built-in. And you have to reverse. Wow. All right. Doesn't matter. We'll deal with this some other time. Tomorrow maybe, or anytime I have to read this. But O(n) squared. Yeah, we got the O(n) squared solution. Does that mean it's a good interview question? I'll decide later. All right. Anyway, that will be it for today. I need to eat. I'll see you guys tomorrow. Adios.